Hello, everyone at Go West Conference. My name is Ulysses, and welcome to Using TinyGo and Lora to monitor and control a hot tub. I apologize I can't be there in person as I'm currently on vacation at Disneyland, which is a great place to be with my family. Just a few agenda items about the things that we'll go over today. First of all, we're going to kind of go over the reason why this project even started to begin with. We'll talk about some hot tub internals, maybe a lot more things that you guys wanted to know about how hot tubs work, and some things that I wish I would have known that somebody would have told me, um, which is, it's always easier knowing after the fact. Next, we're going to talk about what is LoRa as a way to communicate versus Wi-Fi and Bluetooth, which we'll get into that a little bit more. But LoRa is a great low-power technology that is much better at communicating long distances. Then we're going to go over the RP2040, which is a microcontroller that is a very useful and very inexpensive microcontroller for you to play with. And then we're going to talk about TinyGo. TinyGo is a great way to get some Go uh, programs onto microcontrollers such as the Raspberry Pi 2040. Next, I'll give a high level design overview of kind of what we are going to go over, and then we're going to talk about how reverse engineering a serial protocol, even though it looks easy, it's actually a lot harder than it seems. Then next we'll kind of wrap it all up with the lessons learned, and then we'll talk about what's next. So just a little bit about myself. I'm a 10-year gopher that's been doing Go for 10 years, I guess. 2014. It's crazy. I got to attend the first Go conference, which is fantastic, and got to meet a lot of fun gophers along the way. One of those fun gophers that I got to meet was Ron Evans. He created him and the hybrid group created some really cool libraries called GoBot, GoCV, and now TinyGo, which are great things for doing embedded systems programming. Which the crazy part is, if you guys remember that keynote speech, Rob Peck basically said, "Yeah, this isn't built for embedded systems," and Ron's like, "We're gonna change that." So here we are. Another fun thing that I love doing is in my spare time is to fly remote control airplanes. So I like to fly planes. These are not electric. These are gasoline powered planes that run on regular 87 or I guess 91, grade gasoline. A lot of fun and a lot of, gives me a lot of fun things to tinker with. Next, I also got into 3D printing. This is a lot of this, the motivations for this, you guys will see that COVID was definitely some fun times. We, as a family, we decided we're going to get a 3D printer, we're going to have fun, and my kids love it. So they use the thing more than I do, which is a lot of fun. And then lastly, I spend some time, about 2 times a week, I spend up helping out as a planning commissioner for my city. So that's just a little bit about myself. Let's talk about how this thing all started. And kind of how I already alluded to you guys that, like COVID was definitely a fun time. For us as a family with 4 children, it really, really was hard having to homeschool kids and having to, you know, keep ourselves sane when we couldn't go out anywhere was kind of hard. So we kind of decided, what's one of the fun things we love about vacation? It's a pool. Well, the problem is in Utah, you can't really have a pool because it's so cold and it's only good for about, you know, 3 or 4 months of the year. So we decided let's get a hot tub because the kids are going to have fun with that. So I did some basic research, did some digging around and kind of settled in on a hot tub that, I thought, hey, it's built with, industry standard components for the hot tub internals, and they should be good to go, right? I think, let's buy this one. The one caveat there was that, when the salesperson talked to us, they did say, if you want to get one that has Wi-Fi control, we'll need to upgrade you. So that's going to be an extra $600. And my wife and I looked at each other and we're like, yeah, do we really want that? Is that really that important? And I said, you know what? I'll just get that installed later. Not a big deal, right? I can program. I got this. So fast forward to about 3 or 4 months ago, I started to realize like, hey, we need to get some Wi-Fi controls on this thing. Electricity Prices are definitely not cheap when you run a hot tub always at hot all the time. So, and always having to remember like, oh, turn down the temperature before we go to bed, right? Like these are things that you kind of start appreciating the Wi-Fi features of the hot tub. And that's kind of when it's like, okay, it's time to look into this. Let's see. This shouldn't be that bad, right? Like this should be like a $100 module. Get this on Amazon, and we'll get this going. Not a big deal, right? So little did I know that we're gonna dive into a little fun trip of what actually happened. So cracked open the hot tub and looked inside, and oh, it looks like you know, here it is. Here's the part, or here's the control that I have. Now let me go on eBay to see if I can find it. I couldn't find any single Wi-Fi controllers for this thing. I'm like, are you kidding me? Like this is crazy. Not a single thing. So then at that same time when I was doing some Google searches for this Wi-Fi controller, I found this really cool project. It's basically the work of a bunch of folks that created a GitHub project to reverse engineer the protocol of this Balboa spa controller, and I thought, great, this is all I need. Like, once I have this, I should be good to go, and this shouldn't be that crazy. So we're gonna kind of pause in our little journey, and next we're gonna kind of jump into talking about Lora, and kind of why I decided to go with Lora. So what is Lora? So Lora actually stands for long range. Yeah, it's actually just that, long range. And so basically it's very long range communications. Think about Bluetooth, think about Wi-Fi, right? Wi-Fi is pretty good. It has good range, but not the greatest range, right? Like if you're like me, you probably have a few range extenders in your home if you need that to get good Wi-Fi coverage. So yeah, Wi-Fi is okay, but not that great. And Bluetooth, while it's easy to get stuff out, it does not have super great range. And it uses, and yeah, it has its uses, but for this, not so much. So what makes this project a good choice for using Lora? Well, number one is Lora is great for things that are not very high bandwidth. So for example, sending things like temperature or command, little turn on the pump, turn off the pump. That's not super high bandwidth. So that's one thing. Next part is there's a lot of Wi-Fi interference. So if you look at a hot tub, it's this huge case, right? You've got this big enclosure that's kind of low to the ground, and then you're trying to hopefully get a signal from that to your device inside your home, right? Either your smartphone or your mobile phone or some other device. And that gets kind of hard with things like Wi-Fi or Bluetooth, just from the enclosure, just from getting through enough walls in your house. It's kind of a problem. So this is where Lora is great, because it has such great range that you can pick it up in in a urban setting like your home. The other thing that's also really nice about Lora is the fact that it also runs in a whole separate frequency band than your common Bluetooth and or Wi-Fi signals, which is great. So that's another plus. The last thing that I wanted to talk about with Lora is that it has incredible range. So if you have clear line of sight, you can get about 2 kilometers, which is pretty far. And then there's also other uses that I've seen where people can run Lora on a button cell coin battery for about a good 10 years, which is incredible. So those are kind of the pluses, right? In summary, long range, low power, and just you're on a whole different frequency band from everybody else, so a lot less interference. So let's talk. So that was Lora. That was kind of how I want to talk to the hot tub, right? Great. Next, I want to talk about what microcontroller do you want to use. There's a lot of microcontrollers out there. You'll see so many of them. They have a lot of different features. You can get like an Arduino Uno. You can get the RP2040. There's also a Raspberry Pi that you could use for this, which is a little overkill for this, but it's still an option, right? So there's a lot of options. But I ended up choosing the Raspberry Pi 2040 just because it's such a cheap platform. It has a lot of devices and peripherals, and it's very easy to develop for. The one huge plus also that made me choose the RP2040 is the fact that it has support for compilation in TinyGo, which makes it really really easy to write a Go program and get it burnt onto the board. So the RP2040 is the name of the microcontroller, but however, you're going to want to get a board on that controller. So what I ended up using was the Adafruit Featherwing, and it's kind of in the picture over here. You'll see that. It's nice because it allows you to have USB. You can actually put a battery on there if you wanted to. It's got a lot of really nice peripherals. Great way to go, and super cheap. So if you're working on a microcontroller project that you'd like to kind of experiment and play around with, the Featherwing from Adafruit is actually a great way to go. All right, TinyGo. So whenever you hear people talking about microcontrollers or embedded systems programming, you'll hear people talk about Arduino, right? Which, yes, Arduino is great, and they have huge library supports for many devices, and you'll see great tutorials online from Adafruit or other vendors. Fantastic, but we're here at a Go conference, and so we're going to talk about some other tools that we have at our disposal to do embedded programming. But yeah, like how would you do that, right? I mean, we can use Go today to compile to ARM or Intel or any other microprocessor, but what if you're trying to target something like a microcontroller? How do you do that? So here's where we enter TinyGo. So TinyGo is a compiler that basically compiles Go to even the smallest of places. For example, like a microcontroller. The cool thing about TinyGo is it's not just microcontrollers, but the new hotness of WASM now is something that you can actually do with TinyGo. There's just a lot of cool targets that TinyGo can compile to, and so it's a really cool project. Thanks to Ron Evans and the countless contributors. There's so many of them. I know I've personally met a bunch of the contributors for GoBot, GoCV, TinyGo, and they're fantastic people. TinyGo is such a great project, and it's basically all possible because of all of their efforts. The one thing with TinyGo is it's not hard to use. You just have to get yourself into the mindset that it's a compiler, right? You're now using a new compiler to target some platforms. So the cool thing with TinyGo is that there's number one is you can compile your Go program to a microcontroller for example, in this example, the RP2040, and then there's also some driver code that you can include that you can talk to devices, like you can talk to let's say like a sensor, a temperature sensor, or a light sensor, and a lot of that code is already pre-baked into those driver libraries, which is great. And then if you want to see what other microcontrollers are supported by TinyGo, they have a great list here that I've referenced in the slides. So definitely check it out. Go see what's supported, and yeah, just I think the biggest thing with TinyGo is try it out. And the other thing is remember that you're also not using a full Go, right? Like TinyGo supports most of Go's features, but where you are running in a constrained area and space, that's going to be your limitation. So just remember that when you're developing that, yeah, you're not going to be probably doing a lot of concurrency, although there is some support for it. You're talking about a microcontroller, so just remember that. And the TinyGo project goes over the specifics of what they do and don't support. All right, so just as a quick aside here, so this is kind of my ideal version of what this would look like if we're gonna do this. So we have on the left, we have a hot tub, right? We have the hot tub controller, and according to that awesome GitHub repo that I found, it looks like that hot tub controller talks via RS-485. Now, RS-485 is basically a serial communication protocol that's used by a lot of industrial control devices. Kind of like, if you know, like what RS-232, that's kind of like a UART. If you guys have seen that, like terminal, that's that is the equivalent of what RS 485 versus RS 232. It's kind of like that, but just in a different format, built around you know industrial and automation devices. So that's that part, right? So we need something to convert those signals from the hot top controller into something that we understand. So there's an RS485 controller, and then the next part would be we have the Raspberry Pi 2040. That's a microcontroller that would then interact with that RS485, and then at the end here we would have this RFM 9X LoRa radio. This is the one I ended up using, but there are definitely other models and or makes of LoRa radios out there. That's the one I settled on. It's a great little radio, you know. And then so that would be on the hot tub. So inside the hot tub would be kind of all this hardware here that would kind of sit there and transmit and receive signals. On the other end, you could have a Raspberry Pi Zero W, which is the wireless version of the Raspberry Pi, with this same radio receiving signal. So this is a proposed or my first cut at doing this, and kind of what I was thinking of at the time. The reason why I went with the Pi Zero W versus the Pi 2040 is that we do need to have a bridge. So either we have we're receiving these LoRa signals, we do something with them, and maybe we want to send them to Home Assistant, right? Or maybe we want to send them somewhere else, right? So that's kind of why I ended up going with the Raspberry Pi Zero, and just for the Wi-Fi communication part of it. All right, next we're going to go over kind of at a high level how I was thinking about how this software would work. So at the very top here, we'd have some basic, some logic that we would need to write to, get the signals from the RS485 chip, do some reading and writing from that. And then this middle piece here, that's kind of like the key component, right? Is we would need to have some logic there to decode the protocol that the SPA is using. So, this is the secret sauce. This is where we encode, decode the signals coming in and out of the SPA. Then I was thinking, so for example, my SPA has lighting controls that actually has some LED lights that you can turn on, which is kind of fun. And then the temperature control, which is the main part of what I wanted to do. There are other things, like there are pumps that circulate the water and jets and things like that. I didn't want to get too involved with that, so we just kept it as a temperature sensor. And then at the very bottom here, the plan is to add Home Assistant integration, where we could then communicate both in and out of the hot tub via Home Assistant, so that I could already leverage the things that I have. All right, so kind of now that we've gone over all that, the basic ideas of what we thought we're gonna do, let's talk about what actually happened. So this is the part where I say reverse engineering is the easy part of this project until it isn't, because we thought, hey, we should be great, we should be good to go. So cracked open that SPA, checked out that SPA controller, but there's a kind of a problem that I kept running into, and everywhere I looked in this mess of wires, I couldn't find a four pin connector. So in the GitHub project that I found online, they've always made mention of it should be a 4-pin connector. You should be able to connect to that and connect to RS485, and you should start getting some signals. Problem is, I did not see one single 4-port connector here in this box at all. However, instead of a 4-pin connector, if you look here, there's like this, it almost looks like an old telephone wire cable, but it's actually like a flat RJ45 cable. You see there's 2 ports, one on the top and one on the bottom. And these ports look like they're doing something, because at least one of these goes all the way up to the display control, on the top of the hot tub. So where you can set the temperature and turn the lights on, this actually connects to that. So I've said, okay, well, it looks like this is RJ45. This should be doable, right? So luckily, let's just go get an RJ45 connector from Amazon and let's see. Maybe that's the only thing that's stopping us. Let's check it out. So great. So I went and ordered that connector and it came in the mail and great. So went outside, plugged in this connector, did some probing, and through put these wires on, and there's a problem. I'm not getting what I thought I expected to get. So with the RS485, you're supposed to get some voltages that you can test out to see which is the plus and which one is the minus side of that protocol, and I didn't get anything. I could tell there was something going on, so kept playing with it, plugged it in, nothing. So at this point, it looks like, yeah, this isn't even speaking in RS485. It's doing something else. And so that's when I was kind of like, well, great. If this is not RS485, what could it be? So at that point, I'm like, well, I do have an RS232 adapter, that a USB adapter. Let's try that. I mean, at this point, there's not much other options. Let's try what we can get. So I reached into my bucket of parts. Luckily, I had a nice 232 to USB adapter, which is really great. So I plugged that in. I set it at the same settings that the GitHub repo had for the 485 controller, and sure enough, I started receiving messages, which is really neat. So, yeah, as you can tell, if you look at some of this hex code here, it looks like there is something going on. You can tell how some of these messages are repeated. They start with the hex 38 FE6. Looks like that could be some kind of a header. Some of these are variable length. Anyways, like I spent way more 10-minute care to admit in this talk about trying to reverse engineer this protocol. Like there's I looked online, tried to see if anybody could find anything, and there was nothing. So I kind of this is kind of where I hit a wall, where it's like, what's going on here? Like I thought I had the GitHub repo that had this decoded, but that wasn't true. I thought I understood how to decode these messages, and I even tried using how the messages were encoded in their repo, but this was completely different. It was not even the same thing. So yeah, so what kind of happened? So let's talk about lessons learned here. So obviously, this hot top controller is not speaking the same protocol as the one from the Balboa GitHub project. So yeah, like what happened? So as you can tell here in this picture, here's the box. Here's the controller box, right? And you can see it has this nice Viking Spa sticker and logo, but you can't tell what the heck this thing is, right? Is it, it's really what this is just a white labeled, thing that Balboa or that Viking Spa did. They put a sticker over this controller. They called it Viking Spas. You have no idea what it is. Anyway, so once I actually opened up the box and took a look at this, I figured out that this is actually a really old version of Balboa's controllers called the Valley series, the VS controller. And yeah, this is, you guys remember back in slide number 3 or 4 where I talked about the salesperson? Well, this is probably the reason why they quoted me $600 versus what I thought would only be maybe $100 to upgrade this. So that was lesson number 1. Definitely unexpected. I did not think that there would be that much difference in getting the old versus the new, but here we are. So what I actually did find out is that Balboa actually sells another controller called the BP, and that is what the GitHub project is based on. So the nice thing with this BP is that, yeah, you can see that they actually have a 4-pin connector that supports the Wi-Fi module that you can just buy off the shelf. and you can do that, or you can use the GitHub project with it and do it through Home Assistant. Fantastic, everything's great. So the biggest problem that I found is that because this thing is so old, the VS series were so old, there just really wasn't anybody doing any kind of interesting projects trying to reverse engineer it or trying to understand like what was going on with these controllers, because by now like the BP controllers are more ubiquitous and kind of common in the marketplace. So yeah, that's another fun lesson learned there. So at this point, you're all thinking, yeah, I should have just ponied up the $600 and got the Wi-Fi unit, right? That's what I should have done. And I kind of think you guys are right. Like at this point, yeah, like where do I go from here? So kind of where I go from here is that I have two options, right? Option number one, not very cheap, doable, but not very cheap, is to upgrade that spa pack. So if you go back here to this picture, this big box here, this thing, you can replace that. You can actually unplug it. You have to drain your hot tub, unplug this thing, and do some wiring, do some plumbing, and hook it all up, right? And then, now we have a new unit. We can control it via Wi-Fi. It's great, right? That's pretty expensive. It's at least $650 for a new spa pack. So it's not something that I'm going to be doing anytime soon, just because of how expensive it is. Maybe one day, if it breaks, then it's like, okay, time to get a new spa pack. The other option is I could still continue trying to reverse engineer the VS series protocol. The biggest takeaway here is that anytime you're doing any kind of reverse engineering project, it's kind of smart to start off with something simpler. So for me, like while I was doing a lot of this debugging, I ended up dumping a lot of like the serial messages that came through outside as my laptop's connected through some wires, and not the best ideal way to have to work on reverse engineering things as you're trying to read those messages, try to push the button at the top of the unit, looking at to see if the temperature changed or things like that. So that was kind of what made this project hard, is trying to reverse engineer that protocol. Just made it almost impossible to do with what I had there. So I think for my, if I do continue down the road of reverse engineering the VS controller, I would end up buying a little topside controller unit off of eBay for about, I don't know, $50 to $60, and then using that to sniff out the serial communications going on there. That would at least get me what the signal is for making the temperature go up and down, and that would be a great start. But yeah, so what's next? So if once I get, if I'm able to figure out what the protocol is and at least be able to control temperature, I would need to redraw those diagrams. So number one is no more 485. We don't need the RS485 as we're doing RS232, which is the nice thing there is the Raspberry Pi 2040 can handle that. So we can just plug in that, that straight we could plug those right straight into the Raspberry Pi and write some code, and we're good there. So that's a win. But I would need to redraw the system diagram just slightly for that. The other thing I didn't talk about much was with Lora. There's Lora is just the radio, right? It's just you send some bytes, in and out through the radio, great. But there's this concept called LoRaWAN and the Things Network. So LoRaWAN is basically a protocol built like a Mac, built on the physical LoRa radio layer. And it's really neat because you can then basically talk to the Things Network. And what is this Things Network? Well, the Things Network is basically just a bunch of connected LoRaWAN devices and gateways. So the really cool thing about LoRaWAN is that not only can you connect to this network that can basically you have access to and basically a bigger coverage area for your LoRa device, but then there's also really a great integration with Home Assistant. So I think if I continue down this path, I would probably end up going this route. My original intention was just to say, hey, I have LoRa, I have a LoRa radio, I'm going to write some code to then interact with Home Assistant, and that's great. But then I discovered LoRaWAN and this Home Assistant plugin, and I said, wow, this is so much nicer. I'll do that instead. So if you do decide to look at LoRaWAN, there is something that's kind of a little funny with it. So at least in the US. So part of the LoRaWAN standard says, hey, you have to have at least 8 channels to be able to communicate. Think about like having 8 little radios put together in one. That's kind of what that means. So if I were to take my RFM 9X radio that I showed you guys earlier in that block diagram, that and put LoRaWAN on top of that, that wouldn't really work because of how the standard is built. You need to actually have a hardware device that can actually handle 8 separate channels going on at once. So that is one thing that like it's a little confusing. So if you guys start looking at LoRaWAN and saying, oh yeah, I can just do my own gateway, like unless you buy actual hardware that has that many channels, you're not going to be able to do it. So save yourself some time, and there I included a link here to a Seed Studio this multi-platform LoRaWAN indoor gateway. It's really nice. It's a little pricey. It's $140 US, but definitely gets you in the door, gets you into the gateway. So that's definitely the one I'm getting. It's getting delivered to my house right when I get back from my vacation, so I can play around and get to work. But yeah, that's probably the path that I would go, is just get a LoRaWAN gateway and try that out. Great. Well, thank you guys for sticking through this. I know it's been kind of a long talk and a little bit all over the place, but hopefully you guys have learned a few things about IoT and what you can do with TinyGo. TinyGo is really great. They have really great example projects. So if you want to pick up a Raspberry Pi 2040 and just start playing around, I think that's a great way to go. We talked about a little bit about LoRa as a way to communicate via radio through long distances and low power. That's also great. You can buy some really great off-the-shelf little boards that you can play with and experiment with. That I suggest you if you're interested in any of this, like definitely check that out. And if you guys have any other questions, let me know. Feel free to contact me. My email here is uflynn@hotmail.com. And I appreciate you guys sticking through this talk, and hopefully makes you want to go play with some devices and learn how to do some things in the physical world. Thanks, everybody. We'll see you.